Multivariable integration. In today's lecture, we are going to take a very beautiful topic of integration, which is called multivariable integration. Now, what is multivariable integrals? Basically, these are the integrals which involve more than one variable in the integrand. Now, if you see some of the illustrations on the board, so I have given some of the integrals where you can see in the integrand we have more than one variable. Here you can see the integrand is x square y plus 2x, and then we have dx dy. So this is called a double integral. This integral is called a double integral because the number of variables is 2 and we are putting two integral signs. If you see this case, r square sine theta dr d theta d phi, and we have three integral signs. So here you can see the variable for integration are 3, dr, d theta and d phi. So we have three variables of integration, r, theta and phi. So these integrals are called triple integrals. So in today's lecture, we are going to see what are multiple integration and how we are going to solve the multiple variable integration. Got it? See, the prerequisite for understanding the present lecture is that the basic understanding of the integrals. We all know the basic that if we have some integral which say involves an integrand which is a function of x, you can see it is 3x square plus 2, and with d we have x, it means the variable of integration is x, correct? So here you say we are integrating 3x square plus 2 with respect to x. Now this is very primitive integral, the very basic integral skill will be involved here, no multivariable skill. We simply have a single variable x and the variable of integration is also x. So you can solve it by the basic knowledge of integral. Your answer will come to be 3x square will be 3x cube by 3 plus 2 will have the integral 2x, and we will put the proper limit from a to b, and this 3 will get cancelled away. Now you can put the limit, you will get b cube minus a cube plus 2 times of b minus a. Of course, you can factorize a further step taking b minus a as a common factor. So this will be your answer, correct? So this is the very basic integral which we have covered in the fundamental lectures of integral. So we can easily solve an integral of the type when the function is say of any variable. For the prototype for the model, I am saying the function is of x, so f of x, and the variable of integration is x. So we know how to solve these integral, and this is this skill for solving the basic integral is the prerequisite for understanding the present lecture. Got it? Now let's see what is the meaning of partial integration. Suppose we have an integral like the integrand is a function of multivariable, say x, y, z, maybe two variables, maybe three variables, okay? So here the integrand is a function of multivariable. Can you see? So we have integrand function of multivariable, or you can say simply multivariables function. Okay, it can be anything, it can be algebraic function, it can be trigonometric function, okay? And here we are writing dy. So this is making the element, the variable of integration is y, correct? When you are writing dy, it means you are integrating with respect to y. Now let's see what is the procedure of partial integration. Again I repeat, let's see what is the procedure of partial integration. When we use partial integration, when we have an integrand, when we have the integrand a function of multivariable. Again I am emphasizing what will trigger you, which point in the problem, which point in the integration will be a trigger point for making a decision that we have to go for the partial integration when the integrand is a function of more than one variable, okay? So let's see what is the process for partial integration. Firstly, you will decide what is the variable of integration, okay? As a first step, you will decide what is the variable of integration. This is quite easy to decide. You will see which variable or element is present with d. That will be the variable of integration. Like in this integral, y is the variable of integration. In this integral, the variable is y. Got it? Now, what we need to do, you will treat y as the variable. Okay, in the integrand you will treat y as the variable and all other variables will be treated as constants. Again I repeat, you will treat y as the variable and all other variables will be treated as constants and you will integrate accordingly. Correct? Integrate treating y as variable and all other variables as constants. Sorry. So you can write the heading partial integration. So these are the steps for partial integration. First, identify the variable of integration, like in this illustration, y is the variable of integration. And then what do you need to do? The variable of integration will be treated as a variable and all other variables will be assumed will be treated as constants. Let me illustrate. Suppose we have an integral x cube y dy from a to b. Okay. Now you can see we have an integrand which is a function of x and y, correct? In the integrand you can see two variables x and y. Now you will identify the variable of integration. So that is quite simple. You will see with d we have y, so the variable of integration is y. So y will be treated as a variable and in this case x is treated as a constant. Mind it, take heed of this point, x will be treated as a constant and we know the basic of integral, a constant can be taken out of the integral. So we'll get x cube, what is left is y dy and the limit is a to b. Of course these limits will correspond to this variable, the variable of integration. So these are the limits of y, correct? These are the limits of y because x is treated as a constant. You can solve it very straightforward. We'll get x cube and the integral of y is what? Y square by 2. Now put the limits from a to b. So your answer will come to be x cube by 2. You'll get b square minus a square. That is your final answer. Okay, so this is the meaning of partial integral. Of course, so finally you are getting a function of x. Can you see? When you are integrating with respect to y, finally you are getting a function of x because y has definite limits. So it will give you some particular value and what is left is a function of x. So this is the process of partial integration. We are integrating with respect to y. So in this integrand, in this function, y will be treated, number one, remember, y will be treated as variable. All other variables will be treated as constants. We know the basic of integral. Constants can be taken out of the integral and you will integrate accordingly and put the limits. Got it? Now to make the process more clear, we are doing some of the illustrations. Same integral of x square y dy from a to b and we will integrate partially. So here we have dy, so we'll integrate with respect to y. So x is treated as what? Constant. So x square will be taken out of the integral and this is a to b y dy. So we'll get x square and this is very straightforward integral y square by 2 within the limits a to b. So we'll get x square by 2, put the limit b square minus a square. This is the answer for this problem. Got it? Okay. Now let's see illustration 2. Integrate partially within the limit 0 to 1 y plus x e index y dx. Now here again the integrand is multivariable, correct? And with d we have x, that is the variable of integration is x. So what we have learned, can you think in this integrand, which variable will be treated as variable and which variable will be treated as constant? So you are integrating with respect to x, correct? So x will be treated as a variable and y will be treated as a constant, correct? So I will write integral of y dx. I'm just breaking the integral and I will be putting the limits in the last step. Okay, e dy dx. So y is treated as a constant, so y will come out of the integral. So what is left is dx plus e index y will come out. What is left is x dx. So your answer will be y, and this will be x within the limits. Now put the limits from 0 to 1 plus e index y will get x square by 2 from 0 to 1. Answer will be, the integral will come to be y 1 minus 0 plus e index y by 2 1 square minus 0 square. So your answer will be y plus e index y by 2. That is your final answer. So I guess you must be very clear by now how we will integrate partially. It's simply straightforward. Simply you have to identify the variable of integration. You will assume that variable as the variable in integrand, all other variables as constants. Now let's see what is the meaning of integrated integral. Now integrated integral is basically the integral with multiple variables, more than one variable, okay, and with multiple integral sign. If it is a double integral, we will have two integral sign, and we will have two elements like dx and dy. If it is a triple integral, we will have three integral signs, and we will have three elements like say dx, dy, dz, or dr, d theta, d phi. It depends. The variable will depend with respect to which we are actually integrating. Okay, so the integral involving multiple variables where process of partial integration is applied, such integral are called integrated integral. Okay, so in this lecture I will take the cases of double integral and triple integral. Both the skills involved in both the integral double or triple will be the same. The only difference is in the number of variables. In the double integral there will be two variables and two integral sign. In the triple integral we will have three variables and three integral sign. Got it? So whenever you see something like this, a multi-variable integral with double integral sign or triple integral sign and two elements like dx dy or three elements like dx dy dz, so such integral are called integrated integral. Okay, now let's see how we are going to solve such integral. Suppose right now I am focusing on double integral, so you can write the heading double integral. So we have an integral like this, some function of x and y, okay, it's a multivariable function. Then we have dx dy, and then we have two limits. Say the limits can be anything depending on the requirement of the problem. Just for the illustration I am putting c to d and from a to b. Now see the process, how we are going to evaluate the integrated integral. Start with the inner integral. We will go from inside to outside, okay. This is very important. Start with the inner integral. What it means, see, if you have something like this, c to d, a to b, f of x comma y, dx dy. So just focus on this integral sign, inner one. So you will get from this thing, you can say the rightmost integral sign. Let me change the color. The rightmost integral sign till the first element of integration, this thing. This is the innermost integral, correct? So we have to start with this. Okay, we will start with this integral, and this integral is to be done with respect to x, clear? Because here we have dx. So of course the first integral sign, which will be the integral for this inner function, have the limits of x. Got it? Because here often you are not given whether the limits for x or whether the limits are for y. This you have to identify. So this integral sign is appearing where? In the inner integral. Got it? This integral sign is appearing where? In the inner integral, and in the inner integral we have dx. So these are the values of x. Just start with the inner integral. We will go inside to outside. For the inner integral, apply the partial integration. For the inner integral, apply the partial integration. Okay. Now what you will do? You will evaluate this integration involving the process of partial integration, which we have learned now. What it means? You will integrate this integral which is inside the green box by using the principle of partial integral. Got it? Let me illustrate one basic. Suppose we have 0 to 2, 1 to 2, x square y dx dy. Got it? So here you can see it is what? An integrated integral, because we have multiple variable and we have two elements of integral, two integral sign. So as I told you, you will start integrating with the inner integral. We'll take this thing and you will integrate it partially. Of course, you can see with respect to x, and these are the limits of course of this variable, that is this is x1 and this is x2. So say, and when you are doing the partial integration, right now we have learned all other variables will be treated as constant. So I'm putting this bracket, see, just for the ease of understanding I am making it like this, that we are focusing on just this inner integral and then I'm writing dy, correct? So what I will have integral of 1 to 2. Now since you are integrating with respect to x, y will be treated as a constant, so y will come out. What is left is x square dx from limit 0 to 2, correct? And this is what? Dy. And ultimately when you are going to solve it, when you are going to solve it by partial integration, you will get a function of y, because x will have definitely be a function of y. So you will have what? 1 to 2, y is a constant, this will be x cubed by 3 within the limits 0 to 2, and what is left outside is dy. So this will come to be 1 to 2, what is left, y by 3 is taken out, we'll get 2 cube minus 0 cube, and we have dy, correct? What you will have? 1 to 2, and this will be 8, so 8y by 3 dy. Now see, now you came to the outer integral. Getting the point? Now this is what? The outer integral. Inner integral has been evaluated using the principle of partial integration. Now we have to integrate this thing, and this is very straightforward. 8 by 3 is a constant, what is left is y dy, and 1 to 2, and of course you know when you are going outside, now this integral sign will have the limits of y, like the inner integral sign were having the limits of x. So this outer integral sign will have the limit of y, this is y1 and this is your y2, got it? Now what we will get? 8 by 3, and the integral will be y square by 2 within the limits 1 to 2. So we'll have, I take 2 outside, so I'll get 8 by 3 into 2, you will have y square, and the limit will be 2 square minus 1 square, you will get 4. So answer will be 4 by 3, 4 minus 1, 3 will get cancelled away, so answer is 4. Got it? So this is how doing a double integral. First we will solve the inner integral, which is the integration with respect to x, so the limit will be of x. Then you will solve the outer integral, that is integral with respect to y, so these limits will be of y. And one thing is very interesting here, you can change the order of integral, the answer will come to be the same. This is something very interesting. You can change the order of integral, okay? There will not be any difference in the answer. So if you want to change the order of integral, I mean what is the order of integral? Here it is dx and dy. So in the inner integral, the variable of integration is x. In the outer integral, the variable of integration is y, and so are the corresponding limits. So you can write this also as something like this, x square y dy dx. So in this case, the first integral element is dy, that is the variable of integration is y. So we have to put the limits of y. Here the limit of y are the outer integral limits 1 to 2. So you can write like the 1 to 2, and then we have the outer integral variable is x. So here the limits of x are 0 to 2. So in this you can write 0 to 2. So this integral can also be written like this. There is no difference in the answer. Of course, the steps may change. Your calculation in steps may change, but your final answer will come to be the same. And what I recommend you, you can convince yourself by solving this integral by the same method and you will get the same answer. Got it? So, are you clear about solving the double integral? Are you clear about solving the double integral? Clear? First, we will take the inner function. If we have something like this, f of x comma y, say now I am writing dy and dx, and this is a and b, and this is c and d. So first of all, you will take the inner integral like this. This is your step 1. And tell me, this integral will be evaluated with respect to which variable? Y. So number 1, it will be evaluated partially with respect to y. And number 2, since if you are confused ki which integral is giving the limits of which variable, so inner integral sign will give the limits of the variable of the inner integration variable, that is y. So a and b, these are the limits of y. Got it? These are the limits of y. And when you will get some value. Okay, you will get some value, say I am saying, and you will get a function of x, because y will have the value, so you will get some function of x. Say I am writing it a bracket x. Now you will, since this value will come as some function of x, now you can write this thing as integral of c to d, and whatever the function comes to be of x, and then you will write dx. Now here you are integrating, this is the outer integral. A and b are what? The limits of y. Correct? Limits of y. Now in the outer integral, you are integrating with respect to x, and of course now these outer limits on the outer integral sign, these are the limits of x. Okay? So this is the method which you can write in your notebook, how we are going to evaluate integral. And similar approach will be for triple integral. We will go from inside to outside. You are going from inside to outside. When you are going on the right side, you are meeting the element of integral, say y, and when you are going to the left side, you are meeting the integral sign. So this is making a complete integral. When you go further one step, here is x and there is an integral sign for the integral of x. In the triple integral, you will have one more d, say dz, and there will be one more integral sign. So the process, the principle will be the same for triple integral. Now let's see some of the illustrations. X square y dy dx. So I guess already I did such type of problem, but just for practice again, I'm solving it. So x square y dy dx. What I recommend for better understanding, what you can do, make the video still, solve it yourself in your notebook, take 2 or 3 minutes, and then resume the video and check your steps with my steps. In this case, we can say it's a multivariable integral. So I will start with the inner integral, something like this. And here we have y. So y will be treated as a variable and x will be treated as constant. I am writing, see, each and every step in a very sophisticated and detailed manner. So I am putting this in bracket for indicating that right now I am just focusing on this portion. So this will come to be integral 0 to 2, and in this integral x is treated as a constant. It will come out, what is left is y dy from 1 to 2, and what is left outside is dx. So this will come to be 0 to 2. We'll get x square. It will have the integral y square by 2 within the limits 1 to 2 dx, correct? So this will come to be 0 to 2, and this will be x square by 2. Now y square, we can put the limit 2 square minus 1 square dx. So this will come to be 0 to 2 x square by 2. We'll get 4 minus 1, that makes it 3 into dx. Now 3 by 2 is a constant, and what is left is x square dx from 0 to 2. So we'll get 3 by 2, we'll get x cube by 3 from 0 to 2. This 3 will get cancelled away, and it also will come to be, I guess, 1 by 2, 2 cube minus 0 cube. So we'll get 8 by 2. So your answer is 4. Got it? This is your answer for this double integral. Okay, now let's see another illustration. We have integral 1 to 3, 0 to 1, 1 plus 4 xy dx dy, correct? Now we will start with the inner integral. We'll go for this integral first, and this integral is being done with respect to x. So x will be treated as variable and y will be treated as constant. So first I'm just writing this in the bracket, just indicating that I'm focusing on this integral and nothing else, correct? And then what is left is dy. Okay. Now this will be 1 to 3, and x is treated as a variable, so I'm just separating it out. I will get to dx plus 4xy dx. I will put the limit afterwards, so if you want you can put right now also, no problem. So what I will get, 1 to 3. Now x is treated as a variable and there is nothing, so the integral will be x from 0 to 1 plus 4y will come out being a constant, and what is left is x from 0 to 1 dy. So you will have 1 to 3, and you will get 1 minus 0. I am putting the limit plus 4 times of y, and the integral will be x square by 2 from limit 0 to 1, and then we will have what, dy. So you will have 1 to 3, and this will come to be what, 1 plus this will be 2y. 1 square minus 1 will be 1, and there is no need to write 1, and what is left is dy. So now we came to the outer integral. This is very straightforward. Now this is a single integral, so we'll get the integral of 1 will be what, y, and this will be 2y square by 2 within the limit 1 to 3. So this will get cancelled away, and you will get 3 minus 1 plus 3 square minus 1 square. So we'll get 2 plus 9 minus 1, 8. So answer is your 10. That is your answer. Got it? So this is how you did this double integral. Now let's see this integral 1 3 0 1 x square plus y square dy dx. Okay. Now I guess you can solve it yourself. So I'll start with the inner integral, and what I suggest again is still make the video, still work it out yourself, get the answer. Okay? So I am writing like this: 0 1 x cube plus y square x dy. This I am taking as the inner integral, and then dx. Now I will evaluate it partially, treating y as the variable and x as the constant. So what is left is 1 3. Now x is treated as a constant, So in the first term, I will get x cube outside, what is left is dy from 0 to 1. In the second term, I will get x outside, what is left is y square dy from 0 to 1, and the outside integral variable is dx. So now 1 to 3 bracket x cube integration will be y within the limit 0 to 1 plus x, and I will get y cube by 3 integration from 0 to 1 bracket dx. So I will get 1 to 3 and I will get x cube, you will get 1 minus 0 plus x by 3 can be taken, 3 can be taken out, you will get 1 cube minus 0 cube, okay, and you will get what? Dx. So your answer will come to be 1 to 3, and this will be x cube plus x by 3 dx, correct? Now we can integrate it straightforward. So your answer will be x4 by 4 plus x square by 2, and 3 is already there in the denominator. So we'll get 6 within the limits 1 to 3. So you'll get what? We'll get, put the limits 1 by 4, 3 power 4 minus 1 power 4 plus 1 by 6, 3 square minus 1 square. So I'll get 1 by 4 and 3, 4 is 81 minus 1 plus 1 by 6, 9 minus 1, that is 8. So I'll get 80 by 4 plus 8 by 6, okay. So what you will get here 20, and this is 4 by 3. So we'll get 20 plus 4 by 3, that is 60 plus 4 by 3. So answer will be 64 by 3. That is your answer. Got it? Okay, now let's see. Till now we were dealing with the variable x and y. The variable can be some other variables like theta, r, phi. So see this integral, we have two integral sign with the limit 0 to pi, 0 to capital R square sine theta dr d theta. Got it? So first of all, just see what are the variables with r. So we have dr and d theta, correct? We have dr and d theta. So this is suggesting us that r and theta are variables. Got it? From the notation of the integral, we can judge r and theta are variables. Now we will start with the inner integral. So we'll go, inner means if you are starting from the middle sign, middle portion, if you are starting from the middle portion, you will get right side, you will get something with d, that is the variable of integration, and you will get the left side, you will get the integral sign that will give you limits of that variable. So if you see the inner integral, this is coming to be this, correct? So can you identify in the inner integral, in the first integral which need to be done partially, what is the variable of integration? Is it r or is it theta? So clearly you can see it is r. So these limits will be the limits of r. So I will solve it 0 to pi, then I am putting the bracket 0 to r square sine theta dr bracket of d theta. Integrate this thing partially. R will be treated as the variable, remember the rule, and theta will be treated as constant. So I will get 0 to pi. Now since theta is treated as constant, sine theta will come out of the integral, and what is left is r square dr from 0 to r d theta, correct? What you will have 0 to pi sine theta r cube by 3 within the limits 0 to capital R, then you have d theta, correct? So this will come to be 0 to pi sine theta by 3, 3 is a constant, r cube minus 0, and this is what? D theta. So I'll get 0 to pi r cube sine theta divided by 3 d theta. Okay? You are at the evaluation of the outer integral, and r is a constant, being the final limit. So r cube can be taken out, 3 is a constant. What is left is sine theta d theta 0 to pi, correct? So I'll get r cube by 3, and the integral of sine is what? Minus cos theta within the limit 0 to pi. So I'll get r cube by 3 minus cos of pi minus cos of 0, correct? We know cos pi is what? So minus of minus 1, and what is cos 0? 1. So I'll get minus of minus 1. So I'll get r cube by 3. This will be 1 and this will be 1. So answer is 2r cube by 3. That is your final answer. Got it? So here we have a double integral, and we just have seen the introduction of new variables like something like theta and r instead of x, y, which we have been doing till now. Now let's see, just going a step forward, what is the meaning of triple integral? So triple integral, as I told you, is simply a multivariable integration involving three variables, three integration variables. Like suppose we have some multivariable function, a function of x, y, z. You remember the basic maths, when we say a function of x, y, z, it is not necessary that all the three elements must be present in the function. That is something very basic of the function which you did in the mathematical tools, okay? A function of x, y, z is not necessarily contains all the three elements. How we decide that it is a triple integral? By this thing. We have dx, we have dy, we have dz. So we have three elements of integration. This is suggesting you three elements of integration. That's why it is a triple integral. And these are the three integral sign corresponding to the three elements. Three integral sign. Okay. So as I told you, no new involved in triple integral. You will start with the innermost integral, solve it partially, then you will come to the outer integral, that is the middle integral, solve it partially, and finally you will come to the third integral, the outermost integral. Let's see the illustration. Say we have triple sign of integral 0 to r, 0 to pi, 0 to pi, r square sine theta cos phi d theta d phi dr. Okay. Now if you see here, there are three elements of integration. Correct? If you see here, there are three elements of integration. So the variables are theta, phi and r. So we have three variables of integration. We have three d's, d theta, d phi and dr, which is suggesting that it is a triple integral. Okay. I told you, you will start with the innermost integral. So this is the innermost integral, and when you are doing for the innermost integral, you will take the first variable of integration, that is first element d theta. This, got it? So I can write it like 0 to r, 0 to pi, bracket 0 to pi, r square sine theta cos phi d theta, bracket close, d phi dr. See the way of writing. I am putting the bracket to emphasize right now my target, my focus is just this integral. We need not to concern what is outside like d phi dr or what are the initial integral sign. And we will evaluate it partially, correct? We will evaluate it partially with respect to which variable? Theta. So theta will be treated as a variable, the basic rule of partial integration. Theta will be treated as a variable and phi and r will be treated as constant, correct? So I will have this integral 0 to r, 0 to pi, bracket. Now small r square will come outside being a constant, cos phi will come outside being a constant. What is left is sin theta d theta from 0 to pi, and we'll get d phi dr, correct? So it will come to be 0 to r, 0 to pi. Now what is left is r square cos phi, and what is the integral of sin theta minus cos theta within the limit 0 to pi, and what is left is d phi dr. Okay, now you solve it. Minus cos theta, if you are putting the limit 0 to pi, you will get minus cos pi minus cos of 0, cos pi is minus 1, so minus of minus 1 minus 1, so answer will be 2, correct? I'm doing as rough working, not making things very much crowded in this integral. So I'll have it 0 to r, 0 to pi, r square cos phi multiplied by 2, and what is left is d phi dr, correct? Now you see, this step your triple integral has been reduced to double integral. Now again you will apply the same rule. You will integrate the inner integral, that is this thing. Now when you are going for this integral, the inner integral, so phi is the variable, the element of integration is d phi, the variable of integration is phi. So phi will be treated as variable, and all other variables, that is r, is treated as a constant. So I'm writing this thing, putting the bracket dr, so I'll get what, 0 to capital R bracket, so I can take 2r square outside the integral. What is left is cos phi d phi dr within the limits 0 to pi, correct? Now what is cos phi? The integral of cos phi is sin phi, so we will have 0 to r, we'll put the bracket 2r square sin phi within the limit 0 to pi, and what is left is dr, correct? We will have the integral 0 to r square sin pi minus sin of 0 multiplied by dr, and this will be 0 and this will be 0, so this whole thing will come, so your answer in this case will come to be 0. Okay, 0 multiplied by anything will be 0. So in this case the answer will come to, had here the limit would have been something else. Let me tell you the skill of integral, because one integral is left. In this case the answer is coming to be 0. So suppose we have something like this. Suppose the limit were 0 to pi by 2. Okay, I'm just different illustration I am dealing just to make you clear with the last step, because here the answer is coming to be 0, so we need not to go to the third integral. Your answer will come to be 0. Now suppose if the limits are 0 to pi by 2, had the limits been 0 to pi by 2, so it would have been 0 to r 2r square, and the integral of sorry, already we did the integral, the limit will be pi by 2 minus 0, so sin pi by 2 minus sin 0, and here what is left is dr. It's 1, sin 0 is 0, so it will be 0 to r 2r square 1 minus 0 dr, so you will get 0 to capital R 2r square dr. Okay, now 2 is a constant, it will come out. What is left is 3r cube by 3 within the limit 0 to r, so your final answer would have been 2 by 3 r cube minus 0, that is r cube. That is your final answer, had the limits been this 0 to pi by 2 in sine in the second integral. What the problem we have in present, for that the answer will come to be 0. This I have shown you different limits. Had the integral not coming to be 0 for sine, then these will be the steps for the last integral. Got it? Okay. So now you are very much clear how to solve the double integral and the triple integral. Now what's next? You can attempt the related DPP involving some of the problems on multiple variable integral, double integral and triple integral to have more fluent practice over such problems. And then after doing the DPP, what you can do, you can attempt the online test in our portal to see how much you have learned. Okay, so here we are completing this topic, the multiple variable integration.